All right, so let me write down the theorem for you guys first. Okay, so the mean value theorem states the following. It says if f is continuous, on the closed interval, and they're going to say the interval is a closed interval a to b, and differentiable on the open interval a to b, then there exists a number c. So then there exists a number c within a to b such that f prime of c is equal to f of b minus f of a over b minus a. So go ahead and write that down. So this theorem says if it's continuous on the closed and differentiable on the open, then there exists a number c. Notice they don't mention anything about the stuff like Rowe's theorem where it says f of a has to equal f of b. They don't say that. They just say if it's continuous and differentiable, then there exists a number c such that f of b minus f of a over b minus a. Does f of b minus f of a over b minus a kind of look familiar? What does that look like? What's the name of the formula that looks like? So maybe I could almost. Yeah, it's the slope formula. Right? That's basically all it is. It's a slope formula. Now, we don't want to write it as a slope formula. We want to leave it the way it is, but it is the slope formula. Okay? So, basically what this formula is saying, because sometimes it's hard to understand what they're talking about, let me just give you an example. Let's say we had a graph that goes like this. Okay? And here's my A, and here's my B. What this function says is, if I just look from A to B, so from here to here, okay, just from A to B, and I figure out all of my slopes, my tangent line slopes. So there's one slope, here's another slope, there's another slope, here's another one, and there's an infinite number of slopes there. Okay, but if I draw a bunch of tangent lines to every single possible point that I can find between A to B, okay, so even one like way up here, okay, and here and there, okay, everywhere. Well, there's an infinite number of tangent lines in between A to B, right? And every single one of those lines is going to have a specific slope. That makes sense? Right? Because a normal line has a slope. What the mean value theorem tells you, if you think about the name, the mean value, it's trying to find the average value of the slope. So it says if you take every single slope and you add it all up and divide it by the number of slopes, then you're going to find your average slope. Okay, f of b minus f of a over b minus a. And then what this thing says, okay, once you have your average slope, so again, your average slope is found by this part of the equation right here. Once you find your average slope, let's just pretend it was 2. Okay? The left side says, so this side right here says, okay, what we're going to do is we're going to take a derivative and find out when your function equals 2. What point on this curve can you find that has the slope of 2? Okay, it has to be there somewhere between that point, but where is it going to happen? Maybe it happens like right there. And that point would be the specific one that has a slope of 2. I know that one's not a 2, but okay, so the idea of the mean value theorem is to say, find your average slope between a certain interval. So that's the f of b minus f of a over b minus a. And then on the left side, you're going to take your derivative of your function and solve for x. And whatever x is, that's the point where your average slope occurs. Okay? So we're trying to find the point where our average slope occurs. So let me give you an example of this. And then we'll do one problem, I think, from your homework, which I forgot to get my book, but I'll get that right now. But let me give you an example. Which example are we on right now? Example 6, maybe? Is it 3? Oh, I'm thinking of the last one. Never mind. Yeah, example 3. So, given f of x equal to 5 minus 4 over x, find all values of x in an open interval from 1 to 4 such that f prime of x is equal to f of b minus f of a over b minus a. What this is basically saying is find the average slope. Okay, use the mean value theorem. Find the average slope, and then once you find the average slope, take a derivative of your function and figure out when that slope occurs. Okay? So let's do the average slope part first. So let's do the f of b minus f of a over b minus a. Now you'll notice a is 1 and b is 4. Okay, that's our interval from a to b, right? So a is 1, b is 4. So f of 4 minus f of 1 over 4 minus 1 is equal to, well, the bottom is 3. That's easy. If I plug in a 4 into my function up top, I get 5 minus 1. Okay? So f of 4 is 5 minus 4 over 4. That's what it becomes. So 5 minus 1. That's going to be a 4. Minus, if I plug in a 1 into my function up on top, f of 1 is equal to 5 minus 4 over 1. 4 over 1 is 4, so 5 minus 4 equals 1. So this is 3 over 3. So that's equal to 1. So my average slope is 1. Okay, so if you were to graph this function, okay, 5 minus 4 over x, they're saying that your average slope is going to be a 1 throughout the interval from 1 to 4. Okay? Now, let's figure out, so we figured out the right side right now, okay? We just did this part right now. Okay? Now we got to figure out the left side, this part. Let's find our derivative. So our derivative, f prime of it, actually before I write f prime of x, let me write f of x in a different form. 5 minus 4x to the negative 1. It's just going to be easier to take a derivative that way. I don't want to use the quotient rule. So my derivative, f prime of x, is equal to 5 plus 4x to the negative 2. Right? Because the derivative of x to the negative 1 would be a negative x to the negative 2. So it's going to make it a positive. Now let me just try to clean this up a little bit. 5 plus 4 over x squared. Oh, wait. Yeah, I'm sorry. I just realized that. Thank you, thank you, thank you. Yeah, the 5 should go away. This should be 4 over x squared. Sorry about that. Or actually, if I can rewrite it the way I had before, negative 4x to the negative 2, which would be positive, actually, should be 4 over x squared. Okay, so there's my derivative. So all I have to do is set my derivative equal to my mean value, right? To my average slope. So 4 over x squared has to equal to 1. Okay? This is my f prime of x. And this is my f of b minus f of a over b minus a. So let's just solve it. This should be a pretty easy solve. 4 is equal to x squared. Okay, because we just multiplied that over. So x is equal to plus or minus 2. Now, you got to be careful here, all right? Because I have two answers, right? One of them is x equals to negative 2. The other one is x equal to positive 2. Where am I supposed to find my answers? Between what to what? 1 of 4. So one of these should not be mentioned. Which one? Negative. So yeah. So I'm going to put since x has to be within 1 to 4. By the way, another way of writing that, you can say since that x is an element from 1 to 4, meaning it belongs in there. Okay, you don't have to do that, but if you kind of want some shortcut, so you don't write so much. But that epsilon means belongs in. Okay, it's an element of. So x is an element of 1 through 4, that interval 1 through 4. So it's somewhere in there. So since x has to be within 1 through 4, then x equals 2. And that would be your answer. Does this make sense? Yeah? Let me grab the book real quick. I'll just do one more with you guys. It goes back by itself. No, it doesn't. Okay. So I got to take it back. So number 42 from the homework. So it says f of x is x to the 4th minus 8x. And then they give you an interval from 0 to 2. The instructions say determine whether the mean value theorem can be applied to f on the closed interval a to b. If the mean value theorem can be applied, find all values of c in the open interval from a to b such that f prime of c equals f of b minus f of a over b minus a. In other words, apply the mean value theorem. If the mean value theorem cannot be applied, explain why not. So in order for the mean value theorem to be applicable, you have to be able to prove that it's continuous. Well, this is a polynomial, so we're good. And that it's differentiable, and since it is a polynomial, we're good. Like it doesn't have any sharp edges. Okay, you could graph it just to see it, and that way you can say like, okay, yeah, it does fit the bill. It's continuous. There's no sharp edges, so we're good. So that does fit. Okay, so we can use this. Now, let's find our mean value theorem. Remember, the mean value theorem is f prime of c equals to f of b minus f of a over b minus a. Okay, so we're going to start with the right side first. I always start with that one. I mean, you don't have to, but I always try to figure out my average slope. So f of b, that would be f of 2 minus f of 0 over 2 minus 0. Okay, remember our a and b are from 0 to 2. F of 2, if I plug in f of 2, I'll kind of do a little bit of scratch work here. F of 2 is 2 to the 4th minus 8 times 2. Now 2 to the 4th, that's 16 minus 16, so that's 0. Now f of 0 is 0 to the 4th minus 8 times 0. So we get 0. So, okay, fine. My average slope, nothing wrong with that. My average slope is 0. Okay, so if you were to look at the interval from 0 to 2 for x to the 4th minus 8x, maybe we'll do that on Desmos just for fun. They say that if you get all the slopes, they basically equal 0. That means there must be the same amount of positive and negative slopes within that interval that match each other up and they cancel each other out. So that's why your slope is going to be an average of 0. All right, let's take our derivative. So we know what f of x is, so f prime of x is equal to 4x cubed minus 8. I'm going to factor out a 4, that's x cubed minus 2. Okay, and we're going to set 4 times x cubed minus 2 equal to 0. Well, 4 equals 0 is not true, so we're just basically looking at x cubed minus 2 equal to 0. Okay, and if we solve, we get x cubed equals 2. And so that means that x has to equal to the cubed root of 2. Okay, since my answer is supposed to be from 0 to 2, always double check to see if your answer is within that interval, which it is. It's like 1.1 something, okay, or somewhere in the ones. So it's fine from 0 to 2. It's going to fit just fine. So here's my answer of x equal to cube root of 2. Okay, so we'll just look at it on Desmos. Let's see what it looks like. I hate typing on this thing on Desmos because it always brings out my keypad. But it was x to the... Hold on 1 second. I brought out the wrong keypad here. So x to the... It always pops up. I apologize. X to the 4th. And then minus 8 times x. I gotta find out if there's a way for me to get rid of that. Okay, from 0 to 2. So it's just right here. So according to that, the average slope, if you take all those negative slopes and all those positive slopes, they should cancel all out. Okay, that's the average. Where is the average slope? Well, do me a favor, guys. I'm not sure, but is the cubed root of 2, actually I could probably do it here, but it might take me forever. The cubed root of 2, so it's 2 to the power of, this is annoying, but it doesn't do it if I have my keyboard on, but it does it if I'm in tablet mode. I don't know why. So it's going to be 1/3. Let me just do that. Yeah, 1.26, right? That's what it's giving me, 1.26 according to this picture, 1.26. So there it is. And if you look, the line at 1.26, it's going to be just a normal straight line. I think I got to put y equals maybe. I don't know why it's not showing up. But, oh wait, never mind. X equal to. Jesus, takes forever. Anyway, you see it's crossing right there. That's the 1.26 x value. Okay, so that's what you're basically finding. They're saying, okay, if you look at this whole interval for a function, it has tons of slopes. Find the average slope and then figure out where that actually happens, where the average slope actually occurs. It could happen more than one place, okay? But usually it's going to happen at least once, okay? That's what it says in the theorem.